Okay, let's dive right into this explainer and unpack the absolutely incredible true story of how Australia's most toxic invader finally met its match. And the craziest part? The hero of this story is an insect smaller than a grain of rice. I am so excited to share this with you today because it completely flips our understanding of invasive species totally on its head. You know, we usually think of ecological battles as these massive, unstoppable forces colliding. But what we're looking at today proves that sometimes the most catastrophic invasions are undone by the absolute smallest, most overlooked details. It's a powerful reminder for all of us that in nature, brute strength really isn't everything.
So think about it for a second. What actually defeats a toxic invader that literally kills crocodiles? It sets up the ultimate David versus Goliath mystery, right? For decades, the entire Australian continent was desperately looking for a bigger predator, maybe a cleverer poison, or some kind of engineered superweapon to stop this unstoppable plague of toads that were just wiping out top predators. But as we're going to see, the thing that actually started winning this war wasn't a bigger monster or a fancy chemical. The answer had literally been underfoot the entire time.
Section 1. The 1935 Ecological Catastrophe. Now, to really grasp the brilliance of the solution, we first have to look at the tragic history and the massive miscalculation that kicked this whole thing off. The sheer scale of this mistake is honestly staggering. Back in June of 1935, exactly 102 squat, warty amphibians arrived from Hawaii to northern Queensland. And they had one single job: eat the beetles that were chewing through the colony's really valuable sugarcane. Within weeks, they were breeding by the thousands. Fast forward a couple of years, and tens of thousands of them were released directly into the cane fields. But here is the tragic irony. The toads couldn't actually climb the cane stalks to reach the beetles, so they just ignored the pest entirely. Fast forward to today, and the descendants of that single, fateful shipment number in the hundreds of millions. They've essentially rolled across tropical Australia in this slow, poisonous tide, advancing tens of kilometers every single year, pushing right toward the Kimberley, which is one of the country's last true wild strongholds. Section 2. An unstoppable chemical weapon.
So what really makes this specific toad so terrifying to an entire continent? Well, it comes down to a lethal superpower. From the exact day it hatches to the day it dies, the cane toad is highly toxic. Tucked right behind the shoulders of an adult are these two large glands, and they produce a substance known as bufotoxin. When an Australian predator clamps down, boom, that milky poison just floods its mouth, and the result is shockingly fast, and it is fatal. We're talking about native northern quolls, huge goannas, deadly snakes, and yeah, even freshwater crocodiles, all dropping dead simply because they bit a toad. You see, Australian animals had zero evolutionary history with this poison, meaning they had absolutely no instinct to leave these things alone.
In some regions, populations of these native predators crashed by more than 90%. 90%! And that happened within just months of the toad front arriving. It was an absolute massacre out there. And because of this devastating number, pretty much everybody, including top scientists for decades, made a massive, understandable assumption. They assumed the toad was completely invulnerable because its poison was just too flawlessly effective. But here is where we get our crucial paradigm shift. The toad wasn't actually invulnerable at all. You have to remember, it spent millions of years back in the Americas perfectly calibrating a weapon against a very specific enemy: vertebrates, animals with backbones. The bufotoxin is perfectly designed to attack the nerve and heart systems of mammals, reptiles, and birds. But an invertebrate, like an ant, it's built on a completely different chassis. It runs on a totally different biological system. So the exact same poison that drops a massive crocodile in minutes does absolutely nothing to an insect. The toad had perfected a defense against the entirely wrong enemy for the place it ended up.
Section 3. The Evolutionary Trap.
Let's see how nature perfectly designed an execution here. The absolute most vulnerable moment in a cane toad's entire life cycle happens right after they transform into these tiny toadlets called metamorphs. I mean, we're talking about a fraction of a gram each. And they do something almost suicidal in the harsh Australian environment. They come out during the day and cluster together on the open, sun-baked mud right at the edge of the water. Now, why on earth would they do that? Well, it's to avoid being eaten by adult cane toads, which hunt at night and happily cannibalize their own young. But by trading one danger for another, these little babies are walking straight into the hunting grounds of the native meat ant, which is an incredibly aggressive insect that actively patrols those exact muddy margins during the daylight.
And it gets worse for the toads. When a meat ant zeroes in and finds a baby toad, the toad does the absolute worst thing possible. It just freezes. Back in the Americas, sitting completely still and trusting your camouflage was a brilliant way to hide from predators that hunt with their eyes. But ants don't hunt with their eyes, right? They hunt by touch and by picking up on scent trails. So a motionless toadlet isn't hidden at all, it's just a stationary meal. Meanwhile, the native Australian frogs that share the same landscape, they have long, strong legs and they sense the ants coming from a mile away. They just hop out of there and flee. The baby cane toad is slow, it has these short little limbs, totally fails to notice the ants closing in, and just relies on a defense mechanism that is completely useless against a scent-hunting insect.
Scientists actually have a formal name for this phenomenon, and it's a great concept to remember. It's called an evolutionary trap. Basically, this is exactly what happens when a behavior that successfully kept a species alive for millions and millions of years in its ancestral home suddenly becomes absolutely lethal the instant it gets dropped into a new environment it never adapted to. For the cane toad, picking open ground, moving around in the daylight, and freezing when attacked, those were once massive advantages. But in Australia, they are a literal death sentence.
Section 4. Weaponizing the meat ant.
So scientists looking at this soon realized they could tip the scales and use this trap to their own advantage. It genuinely became the holy grail of ecological control. As the quote says, the predator, completely by accident, draws a line between the invader and the natives. Because the native frogs already know to outrun the ants, and the invasive toads just sit there and freeze, the ants are selectively devastating the cane toads while totally ignoring the native frogs. Think about how amazing that is. The predator, entirely on its own, naturally enforces a line between the invasive species and the native one. Nobody had to import a brand new species and risk causing another 1935 disaster. The perfect solution was naturally occurring the whole time.
This led researchers at the University of Sydney, specifically a team led by Professor Rick Shine and ecologist Georgia Wardfear, to ask a brilliant, almost cheeky question. Well, if the ants are already doing this, could we maybe just help them do it a bit more? So they ran a field experiment that was wonderfully, almost comically simple. Step 1, identify exactly where the baby toads are emerging from the water. Step 2, place totally ordinary, store-bought cat food bait right nearby. Step 3, watch as massive swarms of native meat ants are drawn to that exact spot during the brief window the toadlets are most exposed. It was incredibly cheap, incredibly low-tech, and completely native from start to finish.
And the results, which were published in major peer-reviewed journals, were just staggering. By simply concentrating the existing meat ants using ordinary pet food, the toadlet deaths shot up more than 4-fold. Let that sink in. It's an unbelievable spike in mortality for the invader, and it was achieved just by slightly nudging a naturally occurring native insect.
Section 5. A pressure, not a cure.
Now, as amazing as all of this is, we do need to keep our science grounded here, because unfortunately, this isn't some magical off switch for the entire cane toad problem. The harsh reality is that the ants are a phenomenal pressure point, for sure, but they only strike the toads at one specific fleeting stage, when they are those tiny metamorphs. The ants can't do absolutely anything against the giant adults. I mean, those things can grow to the size of a dinner plate and weigh up to 2 kilograms. They also completely miss the tens of thousands of eggs that are still sitting in the water. And remember, a single female can refill an entire pond with eggs in just one clutch. So the meat ant is a pressure, not a total cure. It works beautifully, but is just one tool alongside other strategies like traditional trapping and taste aversion training, which is actually teaching native predators to purposely leave the toads alone. But the real, overarching takeaway here, the cane toad was never actually invincible. We just kept measuring it against the wrong enemies for decades.
And that brings us to an incredible final thought. If a tiny native ant could naturally exploit the biological blind spots of Australia's most toxic invader, what else is out there? In our next explainer, we're going to look at an entire island that was completely overrun by a ship-borne predator. We're talking about an animal so successful it quietly erased nearly everything that nested on the ground. That is, until conservationists found one single fatal flaw in its biology that allowed them to clear the entire island. You will absolutely not want to miss how they pulled that off. Thanks so much for learning with me today, and I'll see you in the next explainer.